This is my second lecture video for the Molecules of Life presentation. For this video, I will talk about chemical bonds. Your learning objectives, you need to describe the four types of bonds. There are nonpolar and polar covalent bonds, ionic, and hydrogen. You need to explain the difference between a nonpolar molecule and a polar molecule and explain how an ion forms. This just lists the different bonds. Your textbook mentions van der Waals interactions as well, but we will not be talking about those. Okay, I recommend you watch this video on your own. Before we talk about chemical bonds, you need to understand how electrons are distributed around an atom. So as we talked about in the atomic structure lecture, each atom has protons and neutrons that make up the nucleus, and then electrons that orbit around the nucleus. So that we can talk about atomic structure, we simplify the orbits by calling them electron shells. Now I'm going to go to the whiteboard to demonstrate this. For this example, we are going to use carbon. The symbol for carbon is C. Now, carbon, as you probably remember, has 6 protons. You see the 6 above the symbol. Now, this is the stable representation of carbon, which means that carbon has 6 protons. It always has 6 protons. 6 neutrons, making the atomic mass 12, 6 plus 6, and 6 electrons. That's why it's stable. You have 6 positive charges, 6 negative charges. Well, by stable, I mean it has no net charge. Now we are going to draw the electrons in shells around the nucleus. So you'll have to bear with me while I draw some of these things. So this black circle here, this is the nucleus of carbon, meaning it has 6 protons, 6 neutrons. Now I'm going to draw the first electron shell around carbon. Now there are a few things that I want you to remember here. I'm teaching you about electron shells so that you can better understand chemical bonding. So the number and distribution of electrons in an atom determine the types of chemical bonds that will form between atoms. So you might want to pause the video and write that down. Now, keep in mind here, carbon has 6 electrons. When we draw electron shells, they can hold a certain number of electrons. So the first electron shell holds 2 electrons. So in order for an atom to be stable in the sense that it will not form chemical bonds, it needs to have 2 electrons in that shell. Now, if you are taking chemistry, you will realize that this is a simplification of how electron shells work. But for our purposes, this is fine. So the second and third electron shells hold up to 8 electrons each. One other thing I'm going to write here, the outer electron shell of an atom is called the valence shell. So I'm going to write one more thing, and then you should pause the video, write this down, and then continue to listen to the video. An atom will gain, lose, or share electrons so that the valence shell is full. So go ahead and pause the video now. So hopefully you have all of that written down. Now we will start to create our electron shells for carbon. So this little black dot is an electron, and here is an electron. So I've used 2 electrons. Remember, carbon has 6. Now, this first shell can only hold 2 electrons. And since I have 4 more to distribute, I'm going to have to draw another shell. This is my second electron shell. So I already have 2 electrons. Here's my third electron, fourth, fifth, sixth. Okay. So if you look here, my carbon atom now has 6 electrons. 1, 2, 3, 4, 5, 6. Now this atom needs 8 electrons in that outer shell. Remember, the second and the third shell can hold 8 electrons. And so your atom will gain, lose, or share electrons in order to get that full outer shell. So for carbon, I'm going to draw vacancies here. It needs an electron there, 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 and there. Okay, so carbon has a need for 4 more electrons in order to fill the outer shell and be chemically stable. Now, what that means is carbon will bond with other atoms until it is sharing 4 more electrons. So let me erase some of this here, and I can show you how that will work. We are going to use hydrogen atoms now. H is the symbol for hydrogen. And hydrogen has 1 proton, meaning it has 1 electron. Let's draw a hydrogen atom. This is my nucleus. Here is my electron shell. Now think about how many electrons you need in the first shell. Hopefully you remember that it's 2, but hydrogen only has 1. So hydrogen needs 1 more electron to have a full outer shell. So what will happen here is hydrogen I'm not going to use a symbol, a circle to represent this. Hydrogen will share an electron with carbon. I'm going to draw a line here to symbolize a bond. So what that means is the electron that they're sharing will orbit the other atom on and off. So this is the same right here as saying 2 electrons will orbit the hydrogen atom, and it's like carbon is gaining another electron as well. I'm going to finish drawing this molecule. This is another hydrogen. Here's the first electron shell for hydrogen. Here's its 1 electron. And it's going to be a short bond. Here is the bond between that hydrogen and the carbon. They are sharing that electron. Now, you should realize that if the atom has more than 1 proton, it is not hydrogen, right? All hydrogen atoms have 1 proton. They will share that electron, and down here is another hydrogen atom. And they will share electrons. So the molecule that I just drew for you is called CH4. That 4 would be a subscript. What that means is 1 carbon, 4 hydrogens, and that molecule happens to be methane. So our carbon atom now has 8 electrons in the outer shell. So you would count them like 1, 2, 3, 4, 5, 6, 7, 8. And each one of the hydrogens has 2 electrons in its outer shell because you count the electron that it is sharing with carbon. So that is how chemical bonds are formed. And what I'm showing you here is called a covalent bond. Co meaning share, valent meaning valence electrons or electrons in the outer shell. Well, let's go back to the PowerPoint. This is just telling you how many shells, how many electrons each shell can hold. So what I showed you was how electrons are distributed around the nucleus of an atom. Now we are going to talk about the actual bonds that will form. So I told you that a covalent bond means to share electrons. So covalent bonds, the atoms share electrons, what I wrote right here. Now a nonpolar covalent bond means that the electrons are shared equally around both nuclei. A polar covalent bond means that they are shared unequally. This is a little bit of a complicated concept. So if you look here, what you're looking at is H2 or hydrogen. We can have a hydrogen atom, but hydrogen, the gas that occurs in the atmosphere, is H2. So they are sharing their electrons. Keep in mind, hydrogen needs 2 electrons in that outer shell. So each of these hydrogen atoms has one electron, and so they share those. They essentially now have two electrons orbiting the nuclei. This is non-polar. When we talk about polar and non-polar, you can think of it like the nucleus as a magnet attracting electrons towards itself. Okay, the nucleus is a positive charge, electrons are negative, they're attracted to each other like a magnet. So a non-polar covalent bond means that both atoms have the same strength or power to attract electrons towards themselves. I'll write that down and then explain it in a little more detail. Non-polar covalent bond forms between two atoms with nuclei that have similar attraction for electrons. So it's almost like saying they are the same size magnet. You don't have a super huge magnet and a little one, they're about the same size. So those electrons will spend an equal time orbiting both nuclei. They'll orbit this one, then they'll go around and orbit the other one, then this one, then the other one. Kind of think of it like a figure eight, but I'm going to write spend equal. So a molecule formed with nonpolar covalent bonds, or a nonpolar molecule, does not have a charge to it, meaning it's not positive, it's not negative, right? A charge means positive or negative. So a nonpolar molecule does not have a charge. And we'll revisit this after I talk about a polar molecule, because then you'll be able to contrast the two types of molecules. This is the concept that people tend to struggle with, are polar covalent molecules, which a polar covalent molecule is formed when atoms have polar covalent bonds. We are looking at water in this picture. Water is the example I will typically use for a non-polar, or for a polar molecule, I'm sorry. So what happens with water is that oxygen has a really strong attraction for electrons, like a huge magnet. But hydrogen is really small, it only has one proton. So it's like a really small magnet. And so oxygen will pull the electrons towards its own nucleus and pull them away from the hydrogen. Now, the electrons will still orbit around hydrogen once in a while, but they spend most of their time orbiting oxygen. I'll write down a few notes for you. The oxygen has 8 protons. Hydrogen has 1 proton. You can think of the proton as the size of the magnet. So this is what I just told you. Oxygen has a strong attraction for electrons. Hydrogen has a weak attraction. Now, if you look this up online, you will see the term electronegativity. And that refers to the strength of the attraction for electrons. So oxygen will have a high electronegativity. Hydrogen has a weak electronegativity. I wrote hydrogen nuclei because that's plural. You have one oxygen, two hydrogens. So I would pause the video and write this down. So we talked about the fact that oxygen is pulling those electrons towards its own nucleus. What that does is it gives oxygen an extra negative charge and hydrogen a positive charge. So we will go to the whiteboard. I can illustrate this. I'm going to write the symbol for oxygen. By the way, you do not have to memorize proton number or atomic number for these elements. If I ask you a question that involves atomic number, I will give it to you or give you some way to figure it out. Oxygen has atomic number of 8, meaning 8 protons, 8 electrons. I'm going to draw oxygen here. So we are going to make a water molecule. Remember that the first shell can take 2 electrons, but oxygen has 8 electrons, so I need to draw another shell. So I have 2 electrons, 3. I'm going to put this one right here, 4, 5, 6, 7. We'll put our other one down here. I placed these electrons so that I can show you how water is constructed. It doesn't really matter where you place the electrons. The convention is top, bottom, and the sides. But when electrons are orbiting a nucleus, it's a space that they orbit in. It's not linear, right? They're kind of bouncing all around this space like a cloud. Remember, hydrogen, that's my hydrogen nucleus. Hydrogen has 1 proton, 1 electron. There's my other hydrogen. There we go. Trying to move that, but it doesn't want to move. Oh. Okay, there. Now, oxygen needs 2 more electrons to have a full valence shell, or 8 electrons. Hydrogen needs 1 more electron. So they are going to share electrons. But remember that water is a polar molecule. What that means is that the electrons that are being shared spend most of their time near the oxygen nucleus. So oxygen actually has 10 electrons in its valence shell, right? It's stealing the electrons from hydrogen. It's not permanently stealing them. They still go back to hydrogen every once in a while, but they're mostly orbiting around oxygen. So essentially, oxygen has 2 extra negative charges some of the time. And hydrogen is losing that electron, right? Because it's going over to oxygen. So it essentially has a positive charge some of the time. And I say some of the time because those electrons will go around hydrogen every once in a while. They're not being permanently stolen. So I'm going to write down the definition here of a polar molecule. Now remember, a polar molecule is formed from polar covalent bonds, sharing electrons unequally. So polar covalent bonds are created when 2 atoms have different affinities or attractions for electrons. So in this case, oxygen has a really high affinity or attraction, hydrogen has a low affinity or attraction. So polar molecule is formed with polar covalent bonds. I know I'm writing a lot here, so you should probably pause the video to finish writing. So what I wrote here is a polar molecule is formed with polar covalent bonds, such as water. What a polar molecule means is that there are regions in the molecule with a slight negative charge because it is pulling electrons towards itself. And there are regions with a slight positive charge because the electrons are being pulled away from those regions. So it is a molecule that has different charges in different regions of that molecule. Think of polar as being like the poles, right? Like North and South Pole. They're kind of separated, right? Well, polar means that it has different charges in different regions of that molecule. So let's go back and look at the water molecule. This symbol right here means a partial negative or slight negative charge. So this is a partial positive or slight positive charge. Now, when I ask you questions about bonding, you do not have to know the exact mechanics of how these bonds are formed. However, if there's a covalent bond between 2 of the same elements, 2 oxygen, 2 nitrogen, whatever, that is nonpolar because you have 2 oxygen atoms, they have the same attraction for electrons. So those have to orbit the oxygen atoms equally. But here is a rule of thumb that I do want you to remember. Oxygen and nitrogen have a strong affinity or attraction for electrons. Those are like the big magnets. Carbon and hydrogen have a weak affinity or attraction for electrons. Therefore, anytime you have a bond between oxygen or nitrogen and carbon or hydrogen, it is polar covalent. That you do have to remember. If I give you H2O, you need to know that it is polar. If I were to give you, say, NH3, nitrogen, 3 hydrogen, you need to know that it's polar. And all you have to remember there is oxygen and nitrogen are like strong magnets, carbon and hydrogen are weak. Now, carbon bonded to hydrogen is not polar because they're both weak. Oxygen bonded to nitrogen is not polar because they are both strong. It's when you have a strong and a weak that you get a polar bond. Now we are going to move on into ionic bonds. Now, covalent bonds, the atoms are sharing electrons. In ionic bonds, they are not sharing electrons. What happens in an ionic bond is 2 ions are formed and then they are attracted to each other. We're going to go to the whiteboard again so that I can explain what an ion is. So for this example, the example I usually use for ionic bonding is salt, which is NaCl. Salt can also be iodine, but I think NaCl is the most common form, like table salt. So Na stands for sodium. I'll write that here. Chloride is Cl. Now, sodium has an atomic number of 11. We're going to write chlorine. Oh, I should have said chlorine, not chloride. Chloride's what you call it once it's an ion. So chlorine has 17 protons. 17 is the atomic number. Remember that in a stable atom or a neutral atom, the number of protons equals the number of electrons. So for sodium, you have 11 positive charges and 11 negative charges, which means that you have a neutral atom, no charge. They cancel each other out. I'll just write neutral. I think saying neutral is maybe easier to understand than saying no charge. So similarly, chlorine has 17 positive charges, 17 negative charges. Which creates a neutral atom. Now you have to suffer through me drawing electron shells again. I'm going to draw the nuclei. Hopefully I have enough room to do it here. So we have 1 electron, 2 electrons, We need to draw another shell because sodium has 11 electrons. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. But sodium has 11. So you need one more electron shell. Now, just as with the second shell, the third shell would require 8 electrons so that it doesn't bond, right, to be stable. Now let's look at chlorine. Actually, I'm going to scoot that up a little. Here we have our first shell. 1, 2, now that's full. We go to our second shell and draw our electrons. I know my electrons all look kind of different here. No. Oh, those won't even erase, so I'm just going to draw over them. Okay, so now I have drawn out 10 electrons, but remember sodium has 17. So now we get to draw another electron shell. So we have 11, 12, 13, 14, 15, 16, 17. So notice that chlorine needs one more electron to have a full valence shell. Sodium would need 7, or it would need to lose 1. If it lost this electron, then it would have a full second shell and it would be stable. But they don't share electrons. Chlorine steals an electron from sodium. They're not sharing. The electrons are not orbiting chlorine and then orbiting sodium. Sodium actually steals the electron. So now what you end up with is 11 protons for sodium and 10 electrons because chlorine stole 1. So if you have 11 positive charges and 10 negative charges, that is going to leave you with 1 positive charge. So let's look at chlorine. It still has 17 positive charges, right? Because if you change the number of protons, it would no longer be chlorine. But now it has 18 negative electrons, or 18 electrons, because it stole 1 from sodium. So you end up with 1 negative charge. So these are no longer neutral atoms. The number of electrons has changed in both atoms. So these are now called ions. So an ion is an atom that has lost or gained electrons and carries a charge. So in an ionic bond, you have positive sodium, negative, what you now call a chloride ion, and they are attracted to each other because opposites attract. So an ionic bond is an attraction between an ion with a positive charge, ion with a negative charge. I'll write that here, and then we will go back to the slides. Positively. So pause the video and write that down. I'm going to navigate back to the slides. So here's my image for an ionic bond. I usually refer to sodium chloride when I talk about an ionic bond, an attraction between a positively charged ion and a negatively charged ion. This is what we just went over. Sodium loses its outer electron, so it becomes positive. The final bond that you need to understand is a hydrogen bond. This is one of the most important bonds because it gives water all of its properties. Here is the technical definition for a hydrogen bond. A positive hydrogen in a polar molecule and the negative atom in a different polar molecule are attracted to each other. I know that's a little bit difficult to understand. So I'll write down some information that will help you understand what a hydrogen bond is. First of all, it is always between hydrogen in a polar molecule, usually water, and oxygen or nitrogen or some other really strong atom in another polar molecule. So this is pretty much what I just said, but if I write it down, it might make a little more sense. So you always have a hydrogen that is in a polar molecule. Remember, hydrogen is like a really weak magnet. If it's in a polar molecule, it means it has a slight positive charge. The slightly positive hydrogen is attracted to a slightly negative atom, and I'm going to put usually oxygen or nitrogen. Not always, though. When I say different polar molecule, I just mean another separate molecule. So pause the video, write that down. In this picture, I have two water molecules. Remember, water molecule is a polar molecule. It has a slightly negative oxygen and two slightly positive hydrogen. The polar molecule, because it has regions that are negative and regions that are positive, but they're still in one molecule, they're sharing electrons. It's not the same as an ion because those electrons are not being stolen. They are just shared unequally between nuclei. That's why I call it slightly positive and slightly negative rather than positive or negative. So I have the slightly positive hydrogen. That's the little white atom. Slightly positive hydrogen. It is attracted to a slightly negative oxygen in another polar molecule, in another water molecule. So hydrogen bonding, I told you, is responsible for most of the properties of water. But hydrogen bonding is important in many other molecules as well. So for instance, DNA has 2 strands, double-stranded. Those strands are held together with hydrogen bonds, and it's not a water and a water. It's hydrogen bonding though. Hydrogen bonds are weak. They break, but they reform very quickly, whereas covalent bonds are very strong bonds. And this is important to remember for a lot of biological properties. The last information I am going to give you about polar and nonpolar molecules, and this is taking a step back, but polar molecules are what we call hydrophilic. This means technically water-loving, or they easily dissolve in water. And we are going to talk about that more in the next lecture on the properties of water. But I'm going to introduce it here, and I want you to think about why this is. Nonpolar molecules are considered hydrophobic, technically means water-fearing. So oil is nonpolar. It does not dissolve easily in water, whereas sugar or salt, these have charges and they dissolve easily. That is the end of your chemical bond lecture, and the next 2 lectures will be properties of water. I'm going to divide them up, and pH.